All right, guys, I wanted to tell you about my flamethrower, and that's what I'm going to be showing you really quick. Going to do this nice and quickly and just show you how this thing works. I'm building a flamethrower directly into the Mark 1. The rest of the Mark 1 is coming, but I want to show you this really quick. So there's me in the suit. You can see it's pretty large, and these are the tanks. These are the pressure tanks that are holding the fuel. It goes on the arm there. I'm going to go ahead and turn that off there so we can zoom in here and take a look at it. So mounts directly into the suit like I was saying. And in the normal firing position would be down here, like, I don't know if I can get it in the right position, more or less like that, with the arm down like that. So what we're looking at here, and what I'm going to zoom in here, is we're going to start at the pressurization system. So this is a CO2 tank, and because it stores CO2 is stored as liquid, this can fill up all three of these fuel tanks. This guy right here is this guy right here. This is a little bike like pump or upper thing that they made. So this is just going into a needle. Most of this stuff, almost all of it comes directly off McMaster car, so it's kind of plug and play. Goes into this pressure regulator. There will be another valve coming off. Let's see here. There'll be okay, well, so this goes this way, and then there'll be another valve coming off this way and going down. I'm going to come back to that in a second. This right here is a check valve. So this right here is a check valve. This keeps flow from coming this way. On the off chance, the fuel on this is designed to where it shouldn't flow up here, but on the off chance it does, this stops the fuel from flowing this way. This right here is a pressure relief valve. This throws at, I think, 250. This can regulate up to 220, and the entire system is built the safety factor of about 4. So it's very over designed. This right here is a quick release system here that is a seal, and that's so this entire assembly can come on and off and go into the tanks. And that allows me to get all these things screwed together and stuff, and not have to worry about, you know, getting it together. And I can also take it out to service it and stuff like that. And then the pipes in between these are not they're not modeled, but this would come up to here and then down this loop here, and so that's high pressure air coming into here at 220. This right here is another cap. This is a fill line. This is how it fills with fuel. You can also put a thickening agent to make it kind of like napalm, which just makes it stickier, makes it burn a little bit slower, and makes it shoot a little bit further. Then the fuel will be sitting in these tanks right here. These are going to be tubes that I buy on McMaster car, excuse me. And then these tanks right here are going to be, or the ends of these I'm going to hydroform. So I'm going to make some lathed bits that I'm going to press in with a water pressure washer and balloon these out, and that's how I'm going to make the tops and bottoms of these guys. And then this comes down, and now we have pressurized fuel coming through this way. And then this is a nipple, but this is actually not going to be a nipple. It's going to be directly screwed on and crimped with a crimped hose is going to directly screw on to this. And then this is going to go down to the hand. So let me show you the nozzle first, and then I'll show you the hand all together. So now we're going to look at the nozzle system here. So this is the nozzle system. A lot of it's going to be made out of brass, as you can tell. The rest is going to be made out of stainless. Everything up on the arm was made out of stainless for the most part. This is brass here. The fuel line's going to come in here, and let me turn on the cross-sectional analysis, and we'll talk about how this thing works, because it's pretty cool. It's going to be a machined valve, which is tricky, of course, but not that bad. So here, what we got is the fuel coming in here, and then this is in the closed position. You can see that this is closed. So this is this right here is a nozzle. This is acceleration nozzle, but it also forms the sealing face with this needle in here. So when it's in the closed position, this spring, which I've rated to be this spring at the compression rate that it is here, compressed, even if this thing was completely open and somehow this got blocked somehow and the force was pushing in, this would still be able to overcome that force and push it closed, if that makes sense. And then the force from this air, so this is going to be a solenoid up here. This is how it's going to turn on. So the air is going to come on. We have O-rings here and here. This is a little vent valve so that they can seal properly this way and this way. And then there's another one this way, and there's no need to seal this way because there's just a spring this way. In fact, this is open to atmosphere through this hole right here. I'll say really quickly, this is a brass piece that's going to act as like a dampener as this thing hits. This is chamfered off so it can kind of mushroom. Should be good for, you know, a few thousand firings. Not that I'll ever fire it that many times, but So let me turn the spring off really quick and we'll take a look at how this works. Spring is off, so air comes in, and then, so if you do the solenoid, solenoid opens. When it's closed, by the way, it opens to vent, which is important, that this can clear, and then the spring can return it very quickly. But when it opens, that vent closes, and then air comes pushing in here, 220 psi, and then that will push this way, and that'll hit there, and then this fuel will start coming out down here, and then be accelerated out, and then shot out here. But there's we haven't talked about ignition yet. So before you fire the solenoid, this right here is a glow plug. This is what it looks like right here in real life. And these are used inside of diesel engines they heat up and they help with ignition of the diesel. This is diesel I'm going to be running through my flamethrower. Apparently it's less volatile and a little bit less dangerous. So this will be sitting here. And then this little hole right here, let me go back to the closed position here. This little hole is closed right now. I'll drill a hole through this way, and then I'll thread tap this body in here, and then that'll keep, and then I'll sink in a 440 bolt all the way down to here. So this will just be closed, right? And then this will be a port coming up here and then here. And then this little tiny guy here will then impinge, meaning hit the end of this glow plug, which is glowing red hot. When it hits that, it'll spray around everywhere, and it should catch fire and then burn around in there. And that's what these holes are in here, is to feed that ignition flame. So you have a little bit of fuel coming in here, spraying in here. This entire thing is now like a big flaming mess. And then we're shooting a high pressure stream of fuel through that. This is a very elegant design. I didn't design it really. I borrowed a lot of this design from the Mark II flamethrower, which is a World War II flamethrower. And I just kind of did it in a modern way using some electronics and stuff that they didn't have. Got rid of the manual switch, and I'm using a solenoid, stuff like that. And I'm using a glow plug, which they didn't have back then either, I don't think. They certainly didn't have good batteries back then. This guy right here, I'll just show you really quick. If I take this nut off the top that's going to be machined, I'm going to have another nut that spins around in here. This is going to be 3D printed. And then this thing has threads on it, right? So I can screw down and set the exact distance that I want down there, but then I don't want it moving around. So when I put that piece of plastic on there and then clamp it down, this will be locked into position. And then all I need to do is I have to wire into this. I got to make sure I can still do that. Might have to adjust a few things, but wire these two leads, and then we're good to go. I'll show you really quickly what this looks like on the hand. I don't have this in the final position. I just wanted to give you an idea of where it looks and also give you a sneak peek of how cool the hand is going to look. Right now I have it mounted on top, but I will probably have it mounted over here on the side somewhere, but this just gives you an idea of size and awesomeness on how that's going to look right there. And then the last thing I'm going to show you guys is this right here. This is the wiring diagram for the flamethrower wiring. So what we have here is a battery that I've sized. This is the specs on it. It definitely works for what I have for sure. We'll be able to like run this thing, which draws the most power, the glow plug. They'll be able to run that for almost 5 minutes, which is more than enough. Just a little lithium polymer battery that they use on like RCs. And then I was thinking about having a emergency stop, but I think I might remove that because I think the safety I'm going to have on this is going to be enough. These switches are just going to be right here on my arm, so literally right there, so they're easily to get. This one's going to have one of those covers like in NASA. It's going to have like a cover and then a on switch, and then when that turns on, it'll turn on LED so that I know I'm getting power and also heating up the thing and remind me that that's on. And this is also essentially acting as your safety. If this was like a rifle or something, this would be your safety. So this would turn on, tell you it's on, and then that would open to this and then start heating this up, which runs at 12 volts. This is a 12 volt battery. And then this will be a momentary switch that'll run into a DC transformer. And then upregulate this to 24 volts, which is what the solenoid that I'm using needs. And then so I'll be able to flip the cover, flip the switch, light will come on. I'll need to wait a few seconds for this to heat up, and then I can hit the momentary switch, and that'll open the solenoid and shoot fire and death out the end, which will be pretty awesome. This right here is essentially fully designed. I need to get all the parts, and then I'm going to essentially try to build it directly into the Mark I. We'll see what happens. Thanks for watching, guys. Bye. Guys, I was just rewatching my video, and there's two things I wanted to say, but I failed to say. For starters, you may be wondering how I'm going to get this seal to form here in a way that's going to be effective, because you might imagine getting a really good fit up between these things is really difficult. And it would be difficult if I was just machining it, but it's actually very easy. I'll machine these two surfaces to be very close, and then this right here is going to help. This is going to be a threaded bolt that helps me do this, and I'll just have like a rod that I come down here, and I will put in a lapping fluid, which is essentially just grit of like a certain, size, suspended in like an oil or something like that. You put it in there and then you just spin it back and forth, and they rub each other down to be perfectly fit to each other. So this will be like a perfect fit down to within literally the size of the grit you use. So it can be they can fit each other down to like an arbitrary size. And it's very easy to do. It's almost arbitrary to do. It's like one of the most precise ways to machine stuff. And it literally just uses some like sand. And the other thing that I kind of failed to say that I wanted to iterate on, which is part of the brilliance, I think, of the design of the M2 Flamethrower, is the sealing system here. The nozzle is the sealing system. So when this closes, you don't have any fluid leaking out. One of the problems with the flamethrowers from World War II is that they would have like a valve back here, and then this entire thing would be full of fluid. And so after the pressure disappeared, it's a non-compressible flow, right? So now it's just sitting in there, and you got to tip the thing down and drain all the fuel out, and then you're catching shit on fire that you don't want to catch on fire. So this is really brilliant, because as soon as it closes, all the fuel flow stops, which is great. And then that's also how I'm gonna get that great fit up, is via lapping.